I need to have a 3-hole bolt circle in this piece of aluminium, which has been faced and now turned to 3.5 inches diameter. So I have my disc with a diameter of, hang on a moment, I can't work like this. I'm just going to have a quick tidy up and get this place clear. Where's my airline gone? Now that's better. Where was I? Okay, so the diameter is 3.5 inches and the bolt circle needs to be 2.5 inches. So that's nice and simple. So my pitch circle diameter needs to be placed at 1/2 inch from the edge of the disc. I'll just sense check this with a rule and a marker. Yep, that looks to be about right. And I set my calipers to exactly 1/2 inch to use as a scribe. That looks good, so I'll lock it off at that. I can now carefully use the caliper as a scribe, working gently off the edge of the disc to mark the pitch circle diameter into the bluing. I now need to change my tooling from the tool post and swap it out for something that will cut a shallow V-groove into the face of the job. So I'm going to use this carbide cutting tool that has a 55-degree angle on the point and set that so that it's more or less perpendicular to the face of the disc, so I can then cut a groove at the PCD. I just need to rotate the tool post around, lock it down securely and advance the tool towards the job and line it up with the scribe line. Now if you're like me, doing this alignment by eye, you may well find the need for your highest powered specs, but with care, accuracy can be assured. Once aligned, I simply rotate the lathe spindle by hand while gently applying some cut by advancing the saddle to a depth of approximately 15 thou, or until an even groove has been cut. Once complete, the job is removed from the chuck and I now have a nice groove all the way around the disc at exactly 2.5 inches pitch circle diameter, ready for marking out my bolt hole circle with the dividers. There's a short spigot turned on the back of this disc, so I mounted it in my chuck to prevent it from being unstable against the flat surface. So the mathematical method of determining the positions of a bolt hole circle can be calculated using references from the Zeus data book or the machinist's handbook, and involves calculations for the X and Y axis dimensions of the hole placements when machining. But we don't need that. Maths, where we're going, we don't need any maths.
Great Scott!
Dividers are a wonderful and ancient tool. The simplicity of their form and function belie the fascinating world of geometry that they unlock. You can use them to span a dimension and transfer that size accurately as many times as you like. Find centres, subdivide distances, all without having to use the mathematical side of your brain. The sharp steel points are also used to scribe the line, so there is less chance for errors to creep in. You can use them to form arcs and circles, and divide a circle accurately into segments by walking its radius around the circumference, or simply to explore related geometrical proportions. No numbers, no maths, just measurement in its purest, simplest and most beautiful form. Firstly, a reference point is punched in on the PCD. Maybe not quite so heavy-handedly as this. I forgot I was working with aluminium, but it'll work just fine. Next is to set the dividers to the approximate size for the PCD hole placements, which, if you remember, was calculated as C in the maths workout. But heck, I screwed up that paper, as I don't need the maths. But I suppose I could always unscrew that piece of paper. No, that's cheating. This is the old-fashioned way, after all. What I did instead was to put 2 ballpark pencil marks where I thought the locations would approximately fall on the diameter. Then open up the dividers to span that rough size. Then, using your reference punch mark as a pivot point, locate the other leg of the dividers into the turned groove of the PCD and walk the compasses around and back to the reference point. Here you can see my first guess was a mile off, so I adjusted the dividers to narrow the span, and my next attempt was almost on the money. Just another small tweak to get to final size, and a couple of rechecks to ensure repeatability of the set point. Drop into my groove, one, roll it round, again drop into the groove, lift it up, come back, and it should end up back in the same hole. Now I can scribe across the V groove in both directions of the other two hole placements, ready for centre punching at the intersections of the scribes. Drop your next two dots in. A final check is also then made to ensure that the dot punches are indeed in the correct and final positions, and of course you're not limited to the number of divisions you can make. So for example, if you need 6 holes, you simply half the span of the compasses for twice the number of points. Providing you always return back to the reference point, your divisions will be absolutely precise. And back to the start again. So thanks to this ancient but beautiful measurement device, I now have perfect geometrical placement of my bolt hole circle, without the need for complicated mathematics, calculators or digital readout technology, just like the way it has been done for centuries. And all that's left to do now is centre drill the holes ready for finishing. So, there you go. Easy PCD. Easy peasy PCD. Easy peasy lemon squeezy PCDZ. Okay, I'll leave it there. Thanks for watching.